Hello, this video presentation is about rationalizing the denominator and solving equations. The solving equations will be pretty simple. Well, so will rationalizing the denominator. Rationalize the denominator means to make the denominator a rational number. The rule that we have is there is no radical in the denominator. That means it must be rational. Okay? So how do we do that? Well, let's look at some simple expressions. If I have 7 square root of 2 over the square root of 3, we make it a rational number by multiplying by the square root of 3. Numerator and denominator. The denominator becomes 3, and the numerator becomes 7 square root of 6. 2 times 3 is 6. If we have something like 8 square root of 3 over the square root of 32, we're not going to multiply by the square root of 32, top and bottom. Always simplify first. Always simplify. First. So this is really equal to 8 square root of 3 square root of 32, 16 and 2, 4 square root of 2. 4 square root of 2. But we're not done simplifying. The 4 and the 8 cancel, and we end up with 2 square root of 3 over the square root of 2. And now we multiply by square root of 2 over the square root of 2. Gives me 2 square root of 6 over 2. And these 2's cancel. And my final answer is the square root of 6. Now let's look at what we did here. First of all, we reduced this radical. All right. Then we saw we had an 8 and a 4. We could reduce that. Then we multiplied by the square root of 2, numerator and denominator. And finally, we reduced the fraction one more time. All right. Let's look at one more example. We have 3 square root of 2 over the square root of 8. Another way we can simplify, well, here, let's make this a 2 also. We can simplify this 2 and this 8. Because they are both in a radical, we can reduce it. 1, 4, and we end up with 3 times 1 over 2 times 2. Square root of 4 is 2, or 3/4. And we're done. Simplifying radicals can be really easy, or it can be really hard. If you multiply by radical 32 over radical 32, you're going to start getting big numbers. Always simplify. Always simplify. All right. Now, we're going to be looking at solving equations with no linear term. No linear term. All right. So let's look at something like 4x squared minus 12 equals 0. All right? So the first step is to set quadratic term equal to the constant. So I add 12 to both sides. 4x squared equals 12. I divide by 4, and I find out x squared is equal to 3. Then I square root both sides. I take the square root of both sides. Now this is going to be a little bit different for us, because when we take the square root, we have to take a plus and a minus. Why? Because all numbers, except 0, all non-zero numbers, have a positive and negative square root. This radical symbol is the positive. That's why we have a plus minus. X is equal to plus or minus the square root of 3. Positive square root of 3, negative square root of 3. Let's look at another one. We'll look at two more. 5x squared minus 12 equals 0. I add 12, 5x squared equals 12, and I divide by 5. X squared equals the square root of 12 over the square root of 5. And plus minus. Now we simplify square root of 12. Square root both sides. That's good. We get x equals plus or minus, and then we simplify radical 12. Radical 12 equals radical 4, radical 3, or 2 radical 3 over radical 5. And then multiply top and bottom by square root of 5, and we end up with plus or minus 2 radical 15 over 5. This cannot be simplified because this is in a radical of 15 and the 5 is out. All right, last example. Sometimes you're going to encounter problems that look like this. X minus 2 quantity squared equals 4. To solve this, all we do, because the squared term is by itself, we square root both sides. That's pretty ugly, musket. And we end up with x minus 2 equals plus or minus the square root of 4 plus or minus 2. Add 2, 2 plus or minus 2. That means 2 plus 2, 4, and 2 minus 2, 0. Here, you can give me the actual numbers. When you can do that, you need to do that. All right, this wasn't too complicated, I hope. Have a great day, and I'll talk to you later.